Hello everyone, myself Charanjit Singh. In this part of the video, I am going to continue this chapter periodic table. We were reading about the variation of the properties in the periodic table. So let's see another property, that is electron gain enthalpy. So what is electron gain enthalpy? It is the energy released when a electron is added to an atom. Okay, when an electron is added to an atom, some amount of energy is released, that is known as electron gain enthalpy. Why this energy is released? Due to repulsion of the electron, one new electron is added. Because so you can take an example of chlorine. Okay, chlorine atomic number is 17, 2, 8 and 7 I can write. When an electron is added into it, because to become stable it needs one electron. So when an electron is added to it, it will become Cl negative and it will release some amount of energy out. So this amount of energy which is released by the released by this atom is known as electron gain enthalpy. So I can say one thing: this amount of energy released by only that kind of atom which can gain electron. The elements which lose electron, they cannot show this type of energy because they are not gaining any amount of electron to its particular atom. So let's see the factors on which electron gain enthalpy depends. The first factor is nuclear charge. It is a very important factor. Reason is, an atom can gain electron if it is having a proper nuclear charge, or I can say sufficient nuclear charge. Means if it is having a sufficient nuclear charge to attract electrons from other atoms, then only it can gain electron. So if nuclear charge is more in an atom, if nuclear charge is more, then electron gain enthalpy will also be greater. So next one is size of an atom. If size of the atom decreases, if size of the atom is small, that means nuclear charge will be greater. Okay, again I'm repeating, if a size is small, then nuclear charge will be more. That's why size is small, because nuclear basically decides the size of the atom, nuclear charge. So if size of an atom decreases or is decreased or is small, then what will happen? Nuclear charge will be more, so it can attract the other so it can attract the electron from the other atom. Okay, so electron gain enthalpy will be more. So in case of electronic configuration, I can say the elements which are having stable electronic configuration of half filled and fully filled, uh, completely filled valence subshell shows very small tendency to accept additional electron. Okay, the elements which are already fully filled, for example neon, 1s2, 2s2, 2p6, it is already fully filled, so it will not add any electron to its orbital, to its atom, or to its shell. So they are having very less tendency to add the electron, so they will not show this electron gain enthalpy. They will not show any they will not release any type of energy. So now we will study about the variation of electron gain enthalpy in the periodic table. So as we know, across the period, we have studied in previous video, as we move across the period, means from left to right, nuclear charge increases. If nuclear charge increases, then electron gain enthalpy will also increase, because tendency to gain electron will increase because it is having a sufficient nuclear charge. Okay, same as it is in a case when we are moving down a group. When we are moving down a group, the size of the atom increases. The size of the atom increases as we move down a group, so nuclear charge decreases. So if nuclear charge decreases down the group, electron gain, the tendency to gain electron will decrease. So this property of electron gain enthalpy decreases down the group. Okay, next is electronegativity. What is this electronegativity? Electronegativity can be defined as a tendency of an atom to attract the shared pair of electron towards itself. Again I'm repeating, it is a tendency of an atom to attract the shared pair of electron towards itself in a covalent bond. For example, I can give you example of HCl. Okay, HCl. The atomic number of hydrogen is 1 and chlorine is 287, means 17 atomic number. Okay, so hydrogen requires one electron to become stable, okay, or it can donate one electron to become stable, and chlorine requires one electron to become stable. Okay, so hydrogen shares their one electron with chlorine and they become stable like this, because now their octet is completed. Okay, now their octet is completed. But they should be, when a covalent bond formed between these two atoms, it should be like this, it should be at equal distance like this. But what is happening here, when you can see this in this bonding is just look like this, hydrogen is sitting at a far distance from the shared pair of electrons. Chlorine is having a more they are being more attracted towards the chlorine. These shared pair of electrons are attracted more towards the chlorine. As you can see here, they are more towards the chlorine. The reason behind is that the nuclear charge, because hydrogen atomic number is 1 and chlorine atomic number is 17, so chlorine will have more nuclear charge as compared to the hydrogen. Due to more nuclear charge, more positive charge, chlorine can attract the electron more strongly as compared to the hydrogen. So at the end of the talk, I can say, when HCl bond is formed, the shear pair of electron is attracted more towards the chlorine as compared to the hydrogen. Okay, so this is called electronactivity. More the nuclear charge, more will be the electronactivity, means the power to attract the shear pair of electron towards itself. And to attract the shear pair of electron towards itself, it requires what? A greater amount of what? Nuclear charge. Okay, hope this is clear to you. Now we will talk about the factors on which electronactivity depends. So first one factor is oxidation state. So in general, what we say is the electronactivity increases as the positive oxidation state of the atom increases. Okay, again I'm repeating, electronactivity increases with the positive oxidation state of the atom increases. If oxidation state is more, more will be the electronactivity. This is because with the increase in positive oxidation state, this is because with the increase in the positive oxidation state, the tendency to attract the electron will increase. Okay, because when we lose electron, then the element becomes oxidized. So when it lose electron, the atomic size decreases. That's why electronactivity, it requires more nuclear charge. That's why electronactivity increases with the increase in oxidation state. Next one is type of hybridization. We already have learned that s orbital are nearer to the nucleus than the p, d or f orbitals. Okay, s orbitals are nearer to as compared to p, d and f orbitals because of their higher penetration power that we have discussed in earlier video. Therefore s orbital will have greater electron attracting power or electron activity, because the reason is s orbital are very closer to the nucleus as compared to the p orbital. So I can say s orbital have more electron activity because they are having more nucleus power around it. Next one is nature of substituent. So the electron activity of group varies with the nature of the substituent. This is due to the inductive effect of the substituent group, and we will discuss about the inductive effect detail in organic chemistry about it. So now we will discuss about the variation of the properties along the period and along the group of the for the electron activity. As we know, electron activity basically depends on the nuclear charge, and we know across the period nuclear charge increases. So if nuclear charge increases, that means power to attract the shear pair of electron also increases. So along the period electron activity increases, and down the group, because nuclear charge decreases, that's why variation down a group, generally electron activity decreases as we move from top to the bottom. because nuclear charge decreases, atomic size increases. Next one is analogous properties of second period element. We know elements in a group, they always show similar physical and chemical properties, but the first element of the every group, for example, I can take example of lithium, beryllium, boron. Every group elements which is the first element, they always show a different behavior. They always shows a different behavior. The reason is the small size of the atom. The first element of every group element is having a very small size. Okay. Second one is they are having large charge as to the radius ratio. The reason is next is large charge to the radius ratio. The reason is this, their size is very small as compared to their group elements, because as we move down the group, the number of shell increases, but the charge of the first element as compared to their radius, means their size is very large. Okay, according to their size, the charge they carry is very large. That's why they showed some different behavior. Next one is high electron activity. Because of small size, they are having more charge, more nucleus power, so they are more, they can attract the other electron more tightly or more sufficient. They are more sufficient to attract the other electrons from the other elements, so they are highly electron activity. And they because of their small size, they do not show d orbital, means they do not have d orbital, means non availability of d orbitals in their valence shells. One more thing you can notice here, this analogous, because of this reasons of these second period elements, they basically shows a similar and similar physical and chemical property with the third group elements or third period elements. For example, this you can see here, lithium shows different physical and chemical behavior as magnesium, beryllium shows with aluminium, boron shows with silicon. Okay, so it has been observed that some elements of second period show similarities with the elements of the third period present diagonally to each other. Okay, means this kind of relationship is called diagonal relationship, and this is very important to remember. And the reason behind is that already we have discussed. These are the four reasons that we have discussed already. Now this was all about this chapter. Thanks.